All right, welcome to the deep dive. Today, we're going to be talking about something that is honestly pretty crucial for anyone who's working with data in any serious way, and that's database performance tuning and optimization.
Yeah, absolutely. It's kind of like the art and science of making sure that your database doesn't just, function, but that it really sings, especially, as the amount of data that we're all dealing with just seems to grow
Well, it
exponentially.
really does, right?
Yeah.
So, our mission in this deep dive is to help you guys out there understand why your database might be, I don't know, feeling a little bit sluggish. And even more importantly, I think, to give you some concrete steps that you can actually take to speed things up.
Totally.
We're going to be looking at some core concepts, maybe even get into a few SQL commands just to kind of make things real.
Yeah, absolutely.
Yeah.
Because we're not just talking about theory here. We really want to get hands-on and give people the tools that they can use to make their databases, perform like absolute champions.
So I think a good place to start might be with, just defining what we mean when we say database performance. It's more than just like, does my website load quickly?
Oh, for sure. It's a lot more than that.
Okay.
While user experience is, ultimately what we care about, like you said, it's the outcome. Database performance itself is about how well the database can handle the demands you place on it. So we're talking about things like how quickly it can respond to your requests, those SQL queries you send its way. That's query execution time. Then there's also the matter of resource usage, like how much processing power, memory, and disk space it needs to do its job. And of course, in today's world, it's all about handling many things at once. So we've got concurrency, how effectively it can manage multiple users and their requests without everything grinding to a halt.
Right, because in a lot of modern applications, you've got tons of people hitting the database all at the same time.
Exactly. So it's not just about a single query being fast. It's about the whole system's responsiveness and efficiency, especially when it's under pressure.
And this isn't something you just set up once and forget about, right? As our sources point out, this is an ongoing thing.
100%. Database performance isn't static. It's dynamic. It changes. Think about it. Your data volume grows, your user base expands, the complexity of your application, maybe you add new features. All of these things impact how the database performs.
That makes sense. So continuous monitoring and regular optimization are essential. It's kind of like, tuning a musical instrument to keep it in harmony.
It's a great analogy. You got to keep tweaking things to make sure everything's working smoothly.
So let's say things start to slow down. Where do we even begin? It can feel a bit like, trying to figure out what's wrong with a really complex machine.
It can be daunting, but there are systematic ways to approach it. Our sources highlight that the first step is always identifying those bottlenecks, those points of congestion that are slowing things down.
Makes sense. And one of the first places we should look are those slow running queries, right?
Absolutely. A slow query can bring everything to a crawl. Luckily, we have tools to help us here, like the explain command.
Yeah, explain. I've seen this in some of our sources. What does it actually do?
Explain is a powerful tool. It shows you the database's game plan for executing a specific query. You can see the sequence of steps, the tables it will access, how it will filter and join data.
So it's like peeking behind the curtain and seeing how the database is thinking.
Exactly. So if we run, for example, explain select from employees where department is sales, the output will show us if the database will scan the entire employee table or use a more efficient method like an index.
Okay. And we want it to use an index, right?
Generally speaking, yes, especially for larger tables. A full table scan where the database checks every row can be quite slow.
So explain gives us insights into our queries, but what about the bigger picture, like overall resource usage? Our sources mention watching things like CPU, memory, and disk I/O. How do we keep tabs on that, and what should we be looking out for?
So monitoring those vital signs of your system is super important. There are tools either built into the database or provided by the operating system that let you track CPU usage, memory consumption, and disk activity.
Okay, and let's say the CPU usage is really high. What does that tell us?
It could indicate that the database is doing a lot of heavy lifting, like complex calculations or sorting through huge data sets. And if you're running low on memory, the database might start swapping data to the disk, which slows things down.
And disk I/O, that's basically how much data is being read from or written to the disk, right?
Yep. And if that's consistently high, it might mean your queries are inefficient or that you need more memory.
Got it. Now, our sources also give us this MySQL command shows status, like threads running. What does that one tell us?
That command gives you a snapshot of how many threads are actively working within the MySQL server. High numbers can indicate the database is overloaded. Maybe too many users or some really long-running queries are tying things up.
Okay, that makes sense. And another potential bottleneck you mentioned earlier is lock contention. Can you remind us what that is again?
Sure, so databases use locks to prevent conflicts when multiple processes are trying to access and modify the same data.
Right, like a traffic light system for data.
Exactly. But if there are a lot of processes waiting for locks to be released, it can create a bottleneck and slow things down.
And to look into that, our source mentions another MySQL command. This one is show engine in a DB status. Where should we be looking in that output?
That one's a bit more complex, but it provides a lot of details about what's going on inside InnoDB. You'll want to look for information on transactions, especially those that are waiting. It might indicate that they're stuck behind a lock.
So it sounds like we've got these two approaches. We can analyze individual queries using explain, and we can also look at the overall health of the system using various monitoring tools.
Exactly. Combining those approaches gives you a really good picture of where the problems might be.
All right, so we've talked a lot about finding the problems. Now let's get to the solutions. How do we actually make our queries run faster? One of the fundamental techniques mentioned in our sources is using indexes.
Indexes are incredibly powerful. They're like having a super organized filing system for your data.
Right, because without an index, the database might have to look at every single row to find what you're searching for.
That's the problem, and it can take forever. But an index is a separate structure that's sorted based on the values in a specific column or set of columns. It acts like a lookup table, pointing directly to the rows you need.
Okay, so like if we have an employee table, we could create an index on the department column.
Exactly. So if you frequently need to find employees based on their department, that index can dramatically speed things up. The command might look something like create index AUKUS employee department on employees department.
Okay, so that tells the database to create an index on that specific column. Are there any downsides to having too many indexes, though?
Yeah, that's a good point. While indexes make select queries much faster, they can actually slow down things like inserts, updates, and deletes, because the index itself needs to be updated whenever the data changes.
So it's a balancing act.
Exactly. You only want to index columns that are frequently used in search conditions.
Another tip our sources mentioned is to be more specific with our select statements. We should avoid using select and instead list only the columns we actually need. Why is that such a big deal?
Well, when you use select DB, you're telling the database to fetch every single column from the table, even if you only need a couple of them. It's like ordering a 5-course meal when you only want the appetizer.
Right, just give me what I need, I'm not that hungry.
Exactly. So by explicitly listing the columns you need, like select name, salary from employees, you reduce the amount of data that has to be processed.
Makes sense. Less data to move around means faster queries.
Exactly. And less resource usage overall.
Okay, now let's talk about joining data from multiple tables, which is very common in relational databases. Our sources say using indexed columns in our join conditions is crucial. Why is that so important?
Imagine you have 2 large tables, and you need to find the matching rows. If the columns you're joining on are indexed, the database can efficiently find those matches.
Huh.
But if they're not indexed, it can turn into a really expensive operation where it has to compare potentially every single row from one table with every single row in the other.
Okay, so it's about avoiding those really inefficient comparisons.
Exactly. And for that example you just mentioned, we could have a query like select ET name, D department name from employees, E join departments, D on N E departmented, D departmented equals D departmented. It's important to make sure that E departmented and D departmented have indexes on them.
So if those columns are indexed, the join operation will be much faster.
Precisely. It makes a huge difference.
Another tool mentioned is the limit clause. Can you explain how simply limiting the number of results can improve performance?
The limit clause comes in handy when you don't need every single row that matches your query. Let's say you're building a news feed and you only want to show the 10 most recent articles.
Or maybe you're just testing something and you just want to get a few sample rows.
Exactly. By adding limit 10 to your query, you tell the database to stop retrieving results once it's found 10 matching rows. This can significantly reduce the time it takes to run the query.
Makes perfect sense. Don't do more work than you need to. And this applies to all these optimization techniques, right? We should always test our changes in a non-production environment before going live.
Oh, absolutely. Testing in a safe environment is critical. You don't want to make a change that accidentally brings down your production database.
Yeah, that would be bad.
So it's always a good practice to have a staging environment where you can experiment and make sure everything's working as expected before deploying to production.
Okay. We've covered a lot of ground on optimizing individual queries. But now let's zoom out a bit and talk about how the design of the database itself can affect performance. The sources discuss concepts like normalization and denormalization. Can you explain what those are and how they relate to performance?
Sure. So database design is really foundational. When we talk about normalization, we're talking about organizing data in a way that reduces redundancy and improves data integrity.
Right. So instead of repeating the same information in multiple places, we break it down into separate tables that are linked together.
Exactly. One of the examples we have shows how you can separate employee data from department data. You have an employees table with columns for their name, ID, and a department ID. And then you have a separate department table with details about each department. That way you don't have to store the department name for every single employee.
So normalization is about efficiency and accuracy.
Exactly. It's all about making the data as clean and consistent as possible. But then we have this concept of denormalization, which seems kind of like the opposite. Why would we want to add redundancy back in?
Yeah, that seems counterintuitive.
It can be, but there's a performance trade-off. While normalization is great for data integrity, it can sometimes mean that retrieving data requires joining multiple tables, which can slow things down.
So denormalization is about making those queries faster.
Exactly. Sometimes it makes sense to add a little redundancy back into the database to avoid those expensive join operations. The example shows adding the department name directly to the employee table. That way, you don't need to join tables to get an employee's name and department.
Okay, so it's a trade-off between data integrity and query performance. And it probably depends a lot on the specific application, right?
Absolutely. There's no one right answer. It's all about finding the right balance for your needs.
Another design concept mentioned is partitioning large tables. How does that work and why is it useful?
Partitioning is like dividing a huge table into smaller, more manageable chunks. Think of it like organizing a massive library into different sections based on genre or author.
Right, so you don't have to search through the entire library to find a specific book.
Exactly. We saw an example where a sales table is partitioned by year. When you need to query data for a specific year, the database only needs to look at the relevant partition.
Makes sense. So it's about making those queries more targeted and efficient.
Precisely. And it can be really helpful for managing very large data sets.
All right, so we've talked about optimizing individual queries and the overall design of the database. But what about the software itself, the database management system? Are there things we can tweak in its configuration to improve performance?
Oh, absolutely. The database configuration has a huge impact on how it utilizes the underlying hardware. One of the most important things is memory allocation. Databases use memory to cache data and for temporary storage.
Right, like giving your computer more RAM so it can run programs faster.
Exactly. We saw an example about NiceQuil where you can increase the size of the InnoDB buffer pool using the command set global init buffer pool size equals 1G. This allocates 1 gigabyte of memory for caching data.
So more memory can lead to faster queries.
Often, yes, especially for read-heavy workloads. Another area to consider is connection pooling.
And that's about reusing connections to the database instead of constantly creating new ones.
Exactly. Creating a new connection can be time-consuming. So connection pooling allows you to keep a pool of open connections that can be reused by different parts of your application.
It's like having a pool of taxis waiting instead of calling a new one for every passenger.
Perfect analogy. And finally, some databases offer a feature called query caching.
And that's about storing the results of frequent queries in memory so they don't have to be recalculated each time.
Exactly. It can be very effective for queries that are run frequently with the same parameters.
But it probably depends a lot on the nature of the data and how often it changes, right?
Absolutely. If the data is constantly changing, the cache might not be very useful.
So these configuration settings are very context dependent.
Yes. You need to understand your workload and the specifics of your database system to make the right adjustments.
Okay, to kind of bring everything together, let's imagine we're managing the database for a busy online store. How would we apply some of these techniques in that context?
Sure. So let's say in our online store, users frequently search for products by name. To speed up those searches, we could create an index on the product name column in our products table. The command would look something like create index IDX product name on products. Product name.
Makes sense. We want those product searches to be as fast as possible. What about when customers are viewing their order history? That probably involves a lot of queries on the orders table.
Absolutely. And those queries might be slow if the orders table is large. We could start by analyzing the query using explain and looking for a full table scan. If that's the case, adding an index on the order date column would probably help a lot.
And if the orders table is really massive, we might want to consider partitioning it by year, right?
That's a great point. Partitioning could make those order history queries much more efficient.
So these are all real-world techniques that are used every day to keep e-commerce sites and other data-intensive applications running smoothly.
Precisely. And those are just a few examples. We might also look at optimizing queries that involve joining the orders table with other tables, like the customers table. And of course, making sure the database has enough memory is crucial for performance.
This has been a really in-depth look at database performance tuning and optimization. We've talked about how to identify bottlenecks, optimize queries, design our database effectively, and even tweak the configuration of the database software.
It's been great. And I think what's important to remember is that these principles apply to pretty much any database system out there.
Right. The specific commands and settings might be different, but the concepts are the same.
Exactly. So for everyone listening, as you grapple with your own data challenges or just try to better understand how technology works, think about which of these techniques might be most relevant to you.
Are you seeing slow queries? Is your database struggling to keep up with demand?
Maybe you're designing a new system and you want to make sure performance is baked in from the start.
Remember, database performance is an ongoing thing. It's not something you do once and forget about.
And this brings us to a really important question for you to consider. How can you develop a proactive approach to database performance management?
It's about monitoring your system, analyzing performance data, and making adjustments as needed.
Don't wait for problems to arise. Be proactive. Understand your metrics, optimize your queries, and make sure your database is always running at its best.
Great advice. Thanks for taking this deep dive with us. We hope this has been helpful for everyone out there.
Absolutely. Thanks for having me.